Alright, boys and girls, welcome to video lesson 7-4, our fourth lesson in chapter 7. This lesson is on more proportions and ratios in triangles and other figures. Okay, this first theorem we're going to talk about, it's called the side splitter theorem. It says if a line, this line right here, intersects two sides of a triangle, this one right here, then that line divides the two sides of the triangle proportionally. In other words, x is to y as w is to z. We could have also written, if we wanted to, x is to w as y is to z. You see, when we cross multiply the first one, I'm going to get xz is equal to yw. Well, here, if I cross multiply, I get xz is equal to yw. So you can see that I can write those proportions either way. Okay? This slide here just says the exact same thing, but this is from your book. Again, it says that if a line is parallel to one side of a triangle, so we're going to almost like the converse here, and it intersects the other two sides, then it divides those segments into two proportional lengths. So if BE is parallel to CD, then AB is going to be AB to BC is the same as AE to ED. We also could have said, if we wanted to, AB is to AE as BC is to ED. Okay, so the midsegment of a triangle is just a special case of the side splitter theorem, where the midsegment, like here in this case RQ, or if you want RP, the midsegment is going to go from midpoint. So if R and P are both midpoints, then the segment RP is a midsegment. It's just not just a line segment; it's the midsegment. Okay. Where again it chops them into equal pieces because it's going from midpoint to midpoint. So I think it would be easy to see that those would be proportional. Okay, and the last thing you need to remember about the mid segment is that RP, the length of RP right here. Oh, let me get my pointer. The length of RP right here is going to be half the length of CB, just like in the median or the mid segment of a trapezoid. The same thing happened here. BC is going to be twice as long as RP, or RP is half as long as CB. Okay? So, our third theorem has to do with multiple transversals with multiple parallel lines. So if I have three or more lines intersected by two or more transversals, I'm going to create a whole bunch of proportions. So just looking right here, if this line, we'll call that line 1, and line 2, and line 3, and line 4. If lines 1, 2, and 3, 4 are all parallel, and line 5 and line 6 are transversals, any transversal that cuts these parallel lines is going to create proportional segments. So in other words, we can say A, let me get my pointer, A is to B as X is to Y, or if you preferred, you could have said A is to X as B is to Y. You can say B is to C as Y is to Z, right? You could say A is to C as X is to Z. You could have said A is to X as C is to Z. We could say A plus B is to X plus Y as C is to Z, etc. These are all proportional segments. Okay, why don't we try some problems now? Let's look at this first one right here. In triangle PQR, ST is parallel to RQ, so this is parallel to that. Okay, and PT is 7.5, and TQ is 3, and TR, I'm looking for SR, I'm sorry, SR is 2.5. Find PS, we'll call that X. So I now know that X is to 7.5 as 2.5 is to 3. So we're going to cross multiply. I'm going to get 3x is equal to 2.5 times 7.5. 7.5 times 2.5 is 18.75. And I'm going to divide both sides by 3 now. And x is equal to 6.25. Determine if lines are parallel. In triangle DEF, EH is 3. So this little guy right here is 3. HF is 9. DG is 1/3 the length of GF. So DG is 1/3 the length of GF. So let's call this X and 3X. Is DE parallel to GH? That's what we're trying to find. Well, the side splitter theorem would say that if the sides are proportional, then the lines will be parallel, right? So if we want to say is x to 3, I'm going from this side right here to this side, right? So is x to 3 equal to 3x to 9? Let's see. So is x to 3 equal to 3x to 9? Let's cross multiply and see if these are proportional. 9 times x is 9x, and 3 times 3x is 9x. Yes, those are proportional, which means, sure enough, that these lines must be parallel. Find the perimeter of triangle ABE. That would be this triangle right here in green, ABE. We're looking at the big triangle. I know that we have a side splitter theorem because I have congruent angles right here. These are corresponding angles, so that means that those two lines must be parallel, which means I have the side splitter theorem going on, which now I can say, okay, if I know that 6 is to x, right? So 6 is to x as x is to 24. I'm now going to cross multiply, and I get x squared. X times x is x squared is equal to 6 times 24, which of course is 144. Take the square root of both sides. X is equal to 12. So x is 12. And that makes sense now because 6 is to 12 is 12 is to 24. We want to find the perimeter of ABE. Well, if I highlight this, it looks like in blue I got 6 plus x was 12 plus this piece right here. Well, what is this piece? Well, I know that the proportions of the triangles, they are similar triangles. So just looking at the bottom, I'm going to call line BE. We'll call that A right now. So this is A. A is to 16, the bottom. Bottom is to bottom as the right side. Let's do the right side. We could do either side, but let's do the right side. 12. So AE is 12, and what's the total length of AD? It is 36. So now we know that 36 times A is equal to 12 times 16, which is 192. We're then going to divide both sides by 36. And 192 divided by 36, A is equal to 5.3333 on the calc, which of course we know is 5 1/3. Okay, so A is 5 1/3, which means my perimeter now is going to be 6 plus 12 is 18, plus 5 1/3 is 23 1/3. And I think we're going to check our answer. And sure enough, look at that, 23 1/3 for the perimeter. Let's find x and y right now. Okay, we're going to find x and y. Looking at x first, I'm just looking. It looks like I'm using the multiple transversals with multiple parallel lines. 3y plus 8 is congruent to 5y minus 7. We see that right here, right? We see that 3y plus 8 is congruent to 5y minus 7, which means now 6x minus 5 must also be congruent to 4x plus 3, because they are proportional. In this case, 1 to 1. So I can do 6x minus 5 is equal to 4x plus 3. Let's solve this for x. Minus 4x, add 5, add 5. I get 2x is equal to 8. X is quattro. And then over here, I can do my y's. 3y plus 8 is equal to 5y minus 7. I'm going to subtract the 3y. I'm going to add the 7. I get 5y minus 2y is equal to 15. Y is 7.5. Okay, why don't you guys try to find x and y here for yourselves. First of all, you know that these are parallel lines cut by multiple transversals. So we know that for example, these green lines right here would be proportional. Same ratio as x is to 12. Same ratio as this blue line is to that blue line, or any sums or differences of those segments as well. So go ahead, try to find x and y. Stop the tape, and I'll be back in a minute. Okay, you should have found that x is 9 3/5, y is 28 4/5, and to solve for x, I could have done just simply 8 is to 10, right? As x is to 12, use that proportion, and to solve for y, I can do, keep the same 8 is to 10, but now for y, I need to do the sum, because y is the sum of all these things. So as y is to 10 plus 12 plus 14, which is 10 plus 12 is 22, plus 14 is 36, and there's the proportion that I'm going to use for y. All right, 15. In the figure, x, y, and xz are mid-segments. So remember, these lines right here in red are parallel, and the mid-segment is always half of the base that it's parallel to. And I'll use a different color here. This mid-segment in blue is parallel to this, and it is exactly half. So looking for xz, the length of xz, it's going to be half of 13, so that's 6.5. Looking for the length of st, it's going to be double 7. Do we see st right here? St is right here. Okay. If xy is 7, this is going to be twice as big as that, so that's 14. And angle RYX, that's this angle right here. Okay, as we look at that right now, we know that those two lines are alternate interior angles, that these angles right here are alternate interior angles for these lines, right? Which are parallel because they're mid-segments, so therefore angle RYX is 120 quattro. Okay? Okay, last problem. I want you guys to find the length of XY on your own. That's this length right here. Notice that XY is parallel to this bottom piece. Okay, so go ahead and solve that for X. You can stop, or for XY, you can stop the tape. Okay, so I'm going to let XY be segment X. You should have found that our answer was 2.4. I'm going to let XY be a length of X. So now I can just do a proportion. These are similar triangles now, right? So this triangle in red is similar to this triangle in green. So I can say now that X is to 12 as 2 is to the whole length here, which is 10. And that's the proportion that I would use to solve for X. We do get 10x is equal to 24. Divide both sides by 10. X is 2.4, or 2 2/5. Alrighty, folks, have a great day. We'll see you soon.